I'll talk more from a perspective of the digital. And what I believe is the challenge of bringing digital savvy into a workforce that has not been trained in that in the first place. And I'm going to talk specifically about a study that we undertook at Intel to look at manufacturing very broadly. And I'll echo Don's sentiment that manufacturing as a factory, the oil field as a factory, is a good way to think about it. So right now, we're at that little gray stage. We're at the not connected piece for the most part. Even in factories where we have automation, those machines aren't really connected to the internet. They're sending out data, but the data's really dark data. It's not there for us to be able to use and anticipate with. We're getting to the connect, the unconnected, but you can see in these two places, the operating technology aspects and the information technology aspects are pretty well separated. That's a recipe for challenges and problems and difficulties moving forward. Because it's only when you get to smart and connected things where you start to see the convergence of the intelligent factory, where OT and IT start becoming much more integrated. And so I'll disagree a little bit with my esteemed colleague and say that I think that having petroleum engineers who have just enough information about digital technologies to be dangerous is not a good idea. I think you have to have what we're calling double deep. They have to understand the digital technologies, and they have to understand the physical world in which those digital technologies are deployed. So ultimately, we want to get to that smart factory, and what makes this really interesting, and for your industry in particular, what makes this interesting, is not only do I have old operating systems, I have control systems that don't work together, I have proprietary systems, I have old equipment, but you can see the beginnings of a platform technology where I can take apps and I can have highly specialized apps that perhaps nobody else wants except your industry and specific places in your industry. But they can be so tuned to your needs that you're going to find you're going to eke every last penny out of that crude. And we think this is a really powerful thing. So in that intelligent factory, you have automation, you have control, you have AI and machine learning. It's only when AI and machine learning and automation and control come together that we're really going to realize what we call tunable manufacturing. Right now, it's not real time, and it's not real time for a couple of reasons. Number one, the computer technology really isn't there yet. I don't have time-sensitive networking and time-sensitive internal controls, but we're getting there. That's coming, and it's not too far off. And so when we can reach those things technically, the ability to take the insights that we gain from data and drive real-time control becomes the powerful differentiator. And you're going to want a workforce that understands what that really means. This is really about the power of the edge. It's about that edge, this whole data collection piece. I can put sensors on everything. Now, just because I can doesn't mean I should, which is that other place where the knowledge has to come in. I have to understand what data matters. I have to understand what frequency of that data matters. Do I need to report by event? Do I need to stream? Where do I need to process? I've got a lot of data gathering happening here. And that data gathering somehow has to get transmitted. That sensors have to get transmitted. And we have to be thinking proactively about where I process that data, when I process that data. Am I working in the cloud? Am I working on-prem? So these are some of the questions that are going to drive success in your future operations. And they're not what you're teaching petroleum engineers or what we're teaching engineers in general. But then ultimately, what you really care about from a data prediction perspective is what kind of dashboards can I create that actually yield actionable business value? Well, that's a pretty long leap from business value to sensor data. We have to have engineers who are trained to translate this. And the power of the edge only happens when I have models of the physical world that are digitized, when I have an understanding of the data that drives those models, when I understand the relative importance of data, the signal to noise, and when I can then interpret it. I can't teach a digital technologist to interpret petroleum data. I would agree with you, but you have to be teaching those things simultaneously, I believe. So let me talk about a study that we did. So that's the Intel view, that's the Irene Petrick view. Let me tell you what we did with a study of about 154 people. These were industrial from petrochemical, by the way, was the largest in terms of the number of, not second largest in terms of number of respondents. But what we asked people was, and this was from the operations level to the C-suite. We asked them, what's the future look like? What are your pain points today and what are your challenges? What do you really wish you could do? And I think it's interesting because if we had done this survey a decade ago, we wouldn't have seen that high a percentage of people who had some college education. Keep in mind, this is the operations level clear to the C-suite. The other thing that I think is really telling here is that most of our study were younger. They were the leaders of tomorrow. This is not the opinion of the gray tsunami that's leaving us. And I think that's particularly telling. Because when we think about what these workers want, what they need, what they believe, we can actually accelerate change in ways that probably the C-suite isn't expecting. Certainly, digital systems are going to transform the way in which work is done. There's no question about that. We are going to see more automation. As technology enables real-time, we're going to see more real-time control and tunable precision manufacturing. More interestingly, though, the expectation among all of our survey is that it's going to become more strategic. This is the systems engineering. I'm going to go from optimizing a point in my system to optimizing the solution overall. And we think that's where a lot of yield is going to come and a lot of value is going to come. The last one is a really important one when you start thinking about what's the health of my machine, what's the health of my system, what's the health of my process. Workers want more transparency. I don't want to have to go and fix something that's broken. I want to have baseline data that gives me comparisons that I can actually go and monitor over time so that I can predict beforehand when that machine is going down. So when you think about petroleum engineers in their broadest sense, even your maintenance engineers are going to have to understand this. Today on many factory floors, I have acoustic signals. I have a lot of different kinds of signals, heat, acoustic, heat, noise, temperature, all kinds of things I can do. And yet, when I send an alert to the maintenance person, that person wants to run out to the factory floor and listen. And I'm sure you have those same analogies here in petroleum engineering, because we don't trust the data. That's got to change. And it's only through that symbiotic relationship of data and digital understanding and the deep professional understanding of the physics and the modeling that goes with it that happens. What we did was we looked at personas. We asked people a whole bunch of questions, and we tried to create what are the typical people we'd see on the factory floor, or we'd see in factory operations. And I say factory in quotes. And what we found, this is on the factory floor, we had some very hardcore doers. And these hardcore doers are the ones who are kicking the tires and turning the wrenches and loading the various kinds of things. And what we found was, yes, in a digital future, people expect jobs, some kinds of jobs are going to go away. But nobody believes the human is going to completely go away. They believe that human's going to have different skills. So, and I'll leave these slides with you, and the study is available publicly. I'd be happy to send it to whoever wants it. Bottom line is that we go from doers on the left-hand side today, and we see there are fewer of those doers. But there are some really important things I'll call your attention to. The first one is we currently have the IT doer and the OT doer. Those are two separate people. In most companies, that's still true. Best-in-class companies, that's in the same head, or at least in the same department. And you can see in the future, the prediction that these workers made is that we're going to have a DevOps doer. And that DevOps doer is going to have to understand both halves of that. They're going to have to understand, which speaks to a different kind of curriculum moving forward. The other thing I'll call your attention to is that the hands-on workers that we see today the risk spotter, the factory supervisor, and the hands-on worker really become one of two things. We believe these workers are going to turn into what we're calling that factory pit boss. Imagine somebody who has computer screens across his or her desk that reflect all aspects of the factory or the oil field or the refinery. You can put whatever, substitute whatever name for your environment in there. That person is going to be there just in case. And that person is going to have a lot of data savvy and a lot of production engineering savvy, because that person isn't optimizing a point solution anymore. That person is really monitoring the whole system. The other thing that data is going to do that isn't as obvious in terms of titles is what people do, what people think. We gave people taglines. So here, the operations coordinator, right here, for example, data believer. I want data silos and dark data out of my operational areas. So they're already thinking about dark data. They're already thinking about siloed data. But in the future, that factory optimizer is going to say, my factory is a well-oiled machine where real-time data lets me proactively solve problems. As educators of the next generation of petroleum engineers, that should be something you really think about when you're designing curriculum. Proactively solve problems. Same thing is true here. You don't see as much difference between today and the future for the factory influencers, but you do see in the taglines, once again, that proactive data visibility transparency belief system. If you're going to create those belief systems, you got to create the engineers who know how to interpret them. So navigating the transition, what does that really mean? Well, we all complain about a skills gap. We all know that skills gap exists. What's even more challenging from an Intel perspective is there's an understanding gap. I can collect data, but do I understand the analytics to drive it? Do I know the relative trade-offs between computing at the edge or transmitting to the cloud? Do I understand the bandwidth requirements? Do I understand the way in which new data and machines fit with old data systems and machines? So there's a whole lot of understanding there. And then I mentioned the trust gap, and this is one that's going to be a tough one. It's one that's going to take time. It's one that you guys could do an awful lot to accelerate in your classrooms, in your hands-on examples, in your curricular internships and other kinds of things where you actually force students to not only understand the hands-on piece or understand the modeling sitting in a computer, but understand the integration of those two. So what's that mean for the educational journey? First of all, I think the intelligent factory, the digital oil field, the digitization, the transformation is closer than you think. When we ask pundits, when we ask C-suite leaders, they say this is a decade transformation. The people in this survey who are the future leaders, they're in their low 50s, 40s, 30s, believe this is 3 to 5 years out. Now, they may be overly optimistic. 3 to 5 years and a decade are two different time frames, though, in industry. Need for new skills and new mindsets. I think the skills speak for themselves, the digital skills. It's the mindset transformation that I think educators really have to focus on. What does it mean when we are data-driven? At what point do I trust the data? At what point do I question the data? And the transformation really starts here. It starts in the education. It starts in the classroom. And you hear this from more and more students who are not choosing healthcare but are saying, I want to go build robots. I want to do digital things. So you're going to see an influx of new talent that you haven't seen for a while. So what does that really mean? Well, I've sort of said some of these already, but I'll leave you with these three things. There has to be a deep linkage between theory and practice. And it has to be both on the production end, the molecules end, the chemistry, all of it, and digital. It has to be both ways. You have to create, I believe, in your students, data-savvy statistical thinking. I have to understand probabilities. More than just a Bayesian tree. I have to really fundamentally understand what I'm looking at in these data and in these models. And then I'll leave you with this last one, which I think of, we talk in engineering a lot about soft skills. I think these are critical to actually transforming Industry 2.0 to Industry 4.0 to Petroleum 4.0. You have to think that engineering skills, even excellent engineering skills, are not necessarily transformational skills. There will be fewer workers, but they will be working in teams, and leadership and team dynamics and communication is going to be critical. And those are skills, unless education has changed dramatically in the 3 years I've been gone, we're not doing a real good job at. So that's my 2 cents in 18 minutes or less.